Testing. What's up? I'm Jacob Litzo, your Elixir Mentor, and welcome to another exciting episode of the Elixir Mentor Podcast. This is where we discuss everything related to Elixir, from interviews with enthusiasts, pioneers in the community, to innovative projects and libraries shaping Elixir's future. Today, I'm excited to have Filipe Cabaco. Cabaco. See, I told you I was gonna screw it up. And he's an Elixir developer at Supabase, and he's going to be here to talk about like real-time features and Elixir, and then all the other challenges of creating scalable systems. So, welcome, Filipe. Thank you so much for joining us. And can you just give us a quick little introduction about yourself?
Yeah. So, first of all, thank you for having me in an episode like this. I'm really humbled by it, and I'm really happy to be here. I'm Filipe. I'm an Elixir developer at the moment at Supabase. I'm currently the kind of full-time developer for Supabase Realtime, which is one of the products from Supabase. And I've been working with Elixir. So first work experience was 10 years ago. Or 11, I can't remember. It has been a long time since kind of Elixir 1.1 or something like that. Then unfortunately I had to let go Elixir for a while, but I've came back to Elixir and I've been doing it for the last 3 or 4 years, something like that. But it has always been that ecosystem that's stuck in my mind, even in those early days. And yeah, I'm really fortunate to be working with it daily, even on my free time, which is a problem sometimes because yeah, it's just a language I truly, truly love after seeing a lot of stacks in my life. But yeah, Elixir is the one that I really want to dedicate my time at the moment.
Yeah, I've converted everything that I do to use Elixir. Like everyone says jobs are hard. You just have to kind of make your own jobs sometimes.
Almost, yeah. It's insane the amount of things I kind of go, where can I kind of introduce Elixir into this? Even if I need to do any kind of JS code, isn't there a way to do this in live view or something else before actually going into JavaScript land?
Exactly. Then, well, I hate writing JavaScript hooks because it like makes me rack my. I used to write JavaScript every single day of my life, and for the life of me, I have so much trouble now writing. I can't remember the syntax, but I'm just always Googling syntax. Yeah. When you language flop a lot, you have to always just Google like, what's a for loop again?
Oh yeah, and I don't even think it's if your language flopping a lot. It's more on the side of Google is the best skill of any senior developer.
That's true. Well, like I always say, like my memory is garbage too, so I'll always forget things. But like I'll Google it and I can like refresh my memory really quick. So I like to think that's a skill. So like you said, so you've been involved with Elixir from the very start almost. What got your attention on like the Elixir?
When I was working in a separate company, again, almost 12 years ago or 11 years ago, and I was working with Scala at the time. And I came from a Java world. I've heard about Scala. Scala was promised to be the better Java that existed. And part of the Scala ecosystem, they kind of pushed a lot the idea of using Akka. Akka was a library for active pattern for Scala. So Scala also has pattern matching, and then you had active pattern on top of it. And I went, okay, yeah, this is quite good. And at that time, the Elixir whispers started to appear, I think in Necker News and stuff like that. And then I got interested in it. I got really lucky. I jumped jobs. I got into a job where they were actually starting to do Elixir. They did a node system with Elixir. And yeah, I was able to code a bit for that. And yeah, my mind got completely blown away. Coming from, you have a JVM with actor pattern. Now you have everything without any dependency, plus a bunch of other good things attached to it. It just blew my mind. And since then, I'm kind of all in the ecosystem.
Yeah. When I first started like touching Elixir and figuring things out, because I'm coming from, object-oriented world, JavaScript, a lot of TypeScript. I do like, the type systems. But when I finally wrapped my head around pattern matching and like the pipe
Yeah,
operator, mind was
yeah,
blown. I was sold. Like that's when the syntax became fun to write. And
yeah, yeah,
you
yeah.
don't ever look back.
Yeah, actually, even recently, so attached to the work I'm doing for Realtime, I need to kind of I'm working on Postgres replication, basically consuming the WAL file.
Hmm.
And well, Postgres has kind of a really tricky protocol, which is basically just a giant binary with information. And again, it's one of those things where pattern matching shines so
Oh
brightly that
yeah.
it's insane. And Andrea Leopoldi actually has a really good video, a bunch of videos about using GenTCP to actually do proto hackers, if I'm not mistaken.
Okay.
And it kind of showcases how good Elixir pattern matching is for this lower level kind of stuff. So even just having that um, arrow sign, is this a W? Yes, it is a W.
Yeah.
This is the character W. So I know this is this type of message, so I can consume it in this certain way. That alone is a superpower that I can't even, well, I can imagine in other languages, but it will be a switch case, a bunch of ifs. It will just be too annoying instead of just being a function, consume it,
Yeah.
done. It's brilliant.
Yeah, no, I could imagine, like, yeah, writing that in a different language, just a nasty nested tree of conditionals.
Exactly, exactly. And even the string manipulation of get me the first character, cool, now get me everything else. Get me
Hmm.
the 1 to 32, 33 to 62, or whatever, kind of getting those ranges
Hmm.
in the Elixir world is a pattern matching pattern, and Python is a substring, or
Yeah.
in Go it's a slice. It becomes way trickier to do anything. So yeah, that's the kind of things that really pull me into Elixir.
Yeah, I love that. Now, you mentioned you're working on like the real-time features of Supabase, right?
Yes.
What does that mean? Like what is your day-to-day role? What kind of projects are you working on?
So some time ago, actually, someone in Twitter said Supabase is selling Phoenix channels as a product. In a way, it's kind of that. So we're using Phoenix. Phoenix, as you know, has an abstraction called channels, which is stupidly useful. And we actually are potentially selling it. We're basically have a pusher kind of service where we let people subscribe to Supabase, to Realtime and broadcast via WebSockets.
Okay.
And we also use Phoenix Presence. So even if you look into the pages of our, so in Realtime, the Realtime documentation for in Supabase, there's a section called protocol. You can even see the phx_join. We really are using Phoenix. Then we add a couple of extra layers on top of it. Namely, now there's an authorization element to it, where before connection, before upgrading the WebSocket, the HTTP request to WebSocket, we actually do a quick check against the database because we use RLS policies from Postgres to actually check if the user can connect or not. So
Okay.
we added that layer. And there's another thing we also do, which is Postgres changes. Postgres changes, it's basically a pulling. We pull from the WAL file what actions the user did, inserts, updates, deletes for certain tables, and we just broadcast that to the user. This is extremely useful, as you can imagine. For example, if you have a front end and you want to see, I don't know, new notifications, you could do, I want a trigger on every insert to the table notifications, and you'll just receive that almost instantly. And that's the service we're giving to users.
Okay. If you had to like explain Supabase for people that don't know what it is, what would be like your couple sentence summary of what it is?
We did sell it as open source Firebase for a long time. I think it's a bit more than that because I really like the tagline that Koppel, our CEO, actually uses, which is just Postgres. We really like to focus the idea that we're just using Postgres and then we have some satellite services around it. That will enable you to do backend as a service really well. One of our best products is authorization, which basically kills it in terms of pricing, in terms of scalability. We really have we had examples during the AI boom. I'm not sure if we're still in it, but during the AI boom, we had customers that went from basically 0 to 1 million users in a couple of days. And
Wow.
Supabase had no problem churning that. It's completely fine, and it could actually do more. So Auth was one of the projects that does really well. The storage, it's basically the same. It's, okay, you have Postgres. How can we enable you to use Postgres? If you had a storage kind of service on the side, you have it there. But the idea is really, we just create satellite services around Postgres, but Postgres is the beating heart, which is extremely useful for any backend developer and even front-end developers, because then you can have a really good bridge between, okay, I've done my front-end, I've done my POC, or even my full product in this, but I want to optimize small toggles of it. Then you can do that optimization in the Postgres world, which really makes it way simpler than having something closed source. You can install an extension because you're not limited. You can add, remove indexes if you go really nitty-gritty, which probably will see a performance improvement in your app without much hassle. And that, I think that's the biggest win. It's the fact that we're just Postgres with a bunch of satellite services and fully available, which is extremely useful. And yeah, that's kind of what Supabase is. It's Postgres with satellite services that enables you to build your backend as a service, or be the database for your service, because we allow direct connections without any kind of issue.
Mm-hmm. Now, Supabase is open source, right? Do you see a lot of like outside contributors to it, or is it more of a you can trust what we're doing initiative? Like,
no, we do have. I think we see more contributions on the client libs for sure, because that's probably where people will feel most of the pains. But we do see other kinds of contributions. For example, even Realtime, we had a bunch of contributions to facilitate a bit the self-hosting, because we had some configuration files that were not the best for self-hosting, and that's an area we want to keep improving. And we had external contributions of, let me change this and that, let me just load this new envar. There's always small contributions. We do see them more on the client lib side, again, probably closer to the user, closer to their pains.
Yeah, that makes sense.
But there's other contributions. There's more contributions in the community.
Well, and that's probably a huge benefit to the open source too, is then on the more user side of things, if you're not implementing every front end stack, someone else can do it for you. Yeah,
it's extremely useful. And again, since you can, let's imagine that you find a bug in the client lib, but you don't know where the error comes from. Basically, something the server is returning doesn't make sense. If it's open source, I can go, okay, what client lib am I working on? Edge functions. Cool. If it's in Edge functions, what's the repo for Edge functions? It's this one. Mm-hmm. Okay, then I can look into the code. This is the error that it's throwing when I'm doing this call. You can open an issue and just be more informed of what the hell is happening behind the scenes. And I'm really glad that I'm seeing more and more companies going open source, because this kind of open source is actually a big superpower, because then if your users are more informed, they'll also be more, your troubles will also be easier to fix, right? Mm-hmm. Because they'll know, okay, I know that your server is returning this kind of error on this certain endpoint. When something doesn't happen, it doesn't make sense on my use case. Why is this happening? And then you can go in and say, yeah, that's a bug. It's way faster than I'm in a closed black box of, I've sent something, I've received something that doesn't make sense. Good luck. Mm-hmm. So it's truly a superpower.
Yeah, I am always on the fence about when I hear this use case, I was like, yeah, open source makes sense. And then there's sometimes like when I have like projects that I feel kind of leverage and give me a little bit of a advantage over competitors, I'm like, well, should I open source it? And I'm always on the fence. Like I'm always like yes and no, and I'm so close to making both decisions all the time.
I think that the win there is more on the side of maintaining something isn't free, right?
Yeah.
For example, you can self-host Supabase. There's nothing basically Supabase gives you the keys to the kingdom, do whatever you want. The thing is, at that point, you need to maintain your Postgres, you need to maintain auth, you need to maintain real-time, edge functions, storage. There's a bunch of services surrounding it that you need to maintain. We try to make it as simple as possible by giving you as much configuration as you need, but it doesn't invalidate the scenario of you need to have DigitalOcean pods. I don't know if they call them pods, droplets, that's it.
Yeah, droplets.
You need the droplet for this, for that. You need to connect everything. There's some effort into that. That's probably more expensive than, for example, the Pro tier, which probably will cover most of the cases. I think that's the biggest problem is people think that it's easy to do this kind of stuff. And I think there's a fallacy here, which is if I open source it, people will deploy them by themselves, but most of the people don't want to handle that imagine that you have your open source product selling at $20 a month. That's way cheaper than, I don't know, now I have a droplet. Now I have this. Now I need to do the networking. Now I need to do everything else around it to actually make it work.
Yeah, exactly. Well, like I'm a big fan of Plausible for analytics.
Yeah,
and
so good.
they have the same model, right? But
yeah,
you start to look into it, and hosting your own analytics server, it's just a lot easier to integrate what they offer.
Exactly. It's always that idea of you need to balance hours of work and how much you cost. So let's imagine an average salary of, I don't know, 100K. That divided by hours, dedicated to that work, you probably would have paid 1 year of a Pro tier, for example. And that's the kind of thing that people should measure and understand that probably it's not that big of a problem to open source and just be there. And even open sourcing, imagine that you open source a project and people actually deploy it by themselves. And then they see it's really easy to maintain it, to kind of keep it up. They see that they're spending a lot of time on it. Okay, it's better to switch to the cloud version of it. Okay, cool, easy. Just change the URL, change the API key, potentially give us whatever you need to migrate, and you're done. Meaning that even for customer acquiring can kind of be a big benefit, because then they'll see, okay, I'm taking too much time managing this. Well, I could be just paying $25 and be done with it.
Yeah, they finally see the benefit of letting you hold the reins.
The headaches more than anything.
Yeah, for sure. Well, I think people underestimate the amount of work behind like just DevOps alone and server setup and maintenance. And
yeah, that's actually a good segue for one of the things that we've talked a bit about before starting the stream was distribution and Elixir and all of that. And we can actually go a bit into that because it's one of the pains that Realtime has to suffer.
Just like keeping data synced and everything across every node. Yeah, I'm not too familiar because like I feel like most of my projects I haven't had. They're not big enough, right? So I think a big benefit, but also I don't get to experience the headaches of a distributed systems, right? Is you can vertically scale a lot before you need to do anything else. And then like when speed and other things become issues around the world, you have to be able to have distribute.
We suffer with those problems. For example, with AWS, it's actually not bad. For example, from London to Sydney, since they have a lot of money and underground cables, it basically takes 200, 300 milliseconds for something to reach the other side of the world, which it's quite impressive. But honestly, more impressive for me is the fact that Elixir basically is able to connect all of those regions without any problem. That's the other big win that we see. To give you a bit of context, we're deployed in AWS. We're using Farlight, I think that's the name of it, or Fargate, one of those from AWS, which basically just ramp up a bunch of pods. It's basically managed Kubernetes. And we have, if I'm not mistaken, 6 regions. So we have 2 in the US, 2 in Europe, 2 in Asia. Yeah, I think that's it. Each one of them, the number of nodes depends, but it's, if I'm not mistaken, in the US we have 3 per region. So US East 1 and US West 1, if I'm not mistaken. So yeah, in total, we have not that many nodes because, as you've mentioned, we can actually scale up vertically quite well. It's more a case of redundancy and being sure that, yeah, we don't drop messages. The beauty of it is all of those nodes are connected. So imagine that, why are we doing this? We want to be as close as possible to your database. Since we are just Postgres and we want to consume information from your database, the best way to do it is the node needs to be as close as possible to your database. And so if you ramp up a database from Supabase on the US, it wouldn't make sense for the customer to do the full round trip of, I connect to Realtime via WebSocket. This node connects to your database, goes back, and just keeps doing this loop, which is way bigger, and it would need more connections against the tenant database. Potentially, you'd have dozens of connections just to cater a couple of users. So what Realtime does is we connect to the closest database you have, we consume from that, and then we broadcast to every Elixir node that's connected to that machine. Which means that, so imagine user A has a database on the US, user B is connecting from Europe, they connect to the WebSocket in Europe, which makes the round trip way faster for them. The user in the US connects to the node in the US, but whenever a change happens, the node from the US sends the information, broadcasts the information to the node in Europe, which then broadcasts to the connected user in Europe. This makes everything really fast, and we can see that improvement easily. Because then you're not using. Go ahead.
I'm sorry. When you have all your different nodes in different regions, what kind of latency are you seeing between changes? Like, what kind of systems do you have to put in place to make sure, like, synchronization of data and stuff? Since everything is real time, like someone in Asia changes maybe the same thing that I change at the same time, and like, how do you handle things like that, like race conditions or?
Most of it, again, since it's only one node connecting it, that kind of fixes a lot of the problems, right?
Okay, yeah.
Because since there's only one consumption node, that node then broadcasts to everything else.
Okay.
It kind of works really well. Plus, since we're using Elixir, there's a module from Erlang called RPC, and we basically use that for communication. And it works really well. It's basically just do something in another node and it just works. It's extremely useful. And to give you another example of the RPC usage, imagine that, again, using the user in Europe tries to connect to something in the US. We try to optimize the number of connections we do, so we only keep alive the connection for 5 minutes. If no user appears after 5 minutes, we just disconnect from the database because we don't want to consume resources from the user. It's annoying for them, it's annoying for us, it's annoying for everyone to just keep that hanging Postgres connection, so we kill it. But now imagine that a user connects from Europe to a database that is in the US. What happens then is we basically, from the Elixir node in Europe, we send an RPC call to the node in the US, the right node in the US, to actually connect to the database. And it does this automatically via RPC. Okay. So it's overpowered, and all of it without any special kind of lib. The only lib we use for that is special, we can go into that in a bit. But other than that special lib that I'll probably mention in a bit, everything else is just pure Elixir, pure Erlang, nothing different. And other than that, also Phoenix PubSub that uses the PG node, which is basically a registry of processes that you can send messages and register to topics and so on. Mm-hmm. Again, another Erlang superpower more than anything.
That kind of, we can talk about that a little bit. That kind of falls into the topic of like event-driven architecture. Mm-hmm. And I'm sure with Supabase, that's what you're doing a lot. One, just communicating with Postgres,
Yeah.
and then all your distributed nodes, correct?
Yeah. So again, most of the communication is done via PubSub. So it's who is subscribed to this topic, send it.
Yep.
And again, that's something Elixir, mainly Phoenix, with the PG module abstracts really well. Because then it's a question of, I want to subscribe to this channel and I want to broadcast. We also use events for our internal usage, where we basically say, okay, there's a maintenance thing, which is cache invalidation, for example. We use CacheX. CacheX is the distributed cache that lib. That again is made in Elixir, and a lot of it is just Erlang. We use CacheX to distribute the cache across nodes, and when we need to invalidate something, we just broadcast a message, consume that message, and each node will say, okay, cool, now it's time to invalidate the cache in CacheX done. It becomes really simple to just do these kind of operations because, again, Phoenix PubSub is there, and even if not, PG is there. It's really powerful. And again, it's fully event-driven in the sense of there's a gen server that will receive an handle info at some point, as long as you subscribe to it. And that, again, it's just, it's easy compared to everything else I've seen in the past. It's just way simpler.
So a lot of Supabase's superpowers you're just inheriting from Erlang, essentially.
Completely. To give you another example, there's a really good module. This is a lib from Erlang called Syn, which is, we use it as eventually consistent name registry. So as you know, you have the normal registry where you just want to register your process with a specific name. For example, when you do dynamic supervisor or something like that, Syn is kind of the distributed approach for that. So imagine you will need a name registry that can be shared across the globe to ensure that you only have one process for that one specific use case, which is the usage of, I want one process connected to the tenant database, to the database of the user. Yep. And that's how we do it. It's basically every node will know that, okay, there's a process for this. Who do I need to contact? It's this guy. This guy will talk with the database. And again, this needs to be eventually consistent. Otherwise, if you used something like global or Nisi or something like that, it would need to reach to that point. So potentially we'd have more errors than anything. And there, it's one of the points where scalability and distribution becomes a problem. It's when you have these distances and you expect, okay, my WebSocket shouldn't take 200 milliseconds to connect. When you enter in a site with a WebSocket, it should be instant. Then eventually consistency will help you in that regard, where eventually that connection will happen, but when it happens, the user is already there. So you kind of take advantage of some of the latency for your advantage. And you don't need to rely on synchronous elements to actually achieve it, which is extremely useful. And I do advise to check out the talk from some WhatsApp developers. They had a really good talk about using what they've learned about using RPC in a 100 node cluster, something like that.
Okay.
And even they said something along the lines of, the first thing we did was disable global because global was reaching its limits. Okay. So
can you explain what global means a little bit for everyone?
So yeah, global it's the same as a process registry, but completely distributed across all nodes.
Oh, okay. Yeah. Gotcha.
It's that when there's a way for you to, also in Dynamic Supervisor, you can say, I want to register via global, and you give it the tuple, and it basically says, okay, I've registered it.
That's interesting that that they hit limitations at 10,000 on that, or is there a reason for it?
They had, well, it's WhatsApp. They had a ton of load, and I think when they were bought by Facebook, it kind of goes a bit into that. They stopped to be able to scale that much vertically because they're now under Facebook servers. They had more limitations. They even mentioned that before they were using, I think it's OpenBSD they were using, and they had to switch to Debian. So they had a bunch of limitations on the move to Facebook that actually made them not be able to scale vertically. And they had to scale way more horizontally, sorry, which meant more nodes, which means that every node, if they're all connected, there's a lot of networking happening there across multiple regions, across multiple data centers, some failing, some not failing. So there's a big dance of data going around. And again, connections, since everything is connected to everything, it kind of becomes, I don't know, 10,000 squares.
I feel like that is a really good example of why it's like so much more powerful to vertically scale versus horizontally scale, at least for like the Beam VM, you know, like that's amazing.
I can give you an example that, for example, in our case, our machines are quite powerful, but they're not the top end thing. But we are completely over capacity, honestly, not over capacity, sorry, over provisioned. We just want to be sure that the service doesn't fail, basically. But it's there. I remember, I think it was Pinterest. They mentioned that they went from, I don't know how many servers to 2 or 3 servers, and most of it was just for resiliency. It's basically if one server goes down for some reason, the load balancer knows how to point to something else. And even on that story, you have stuff like how easy it is. So in other languages, if you try to do a cluster, what do? You might scale horizontally, but you'll need a message buffer in the middle, some sort of RabbitMQ or Kafka or some magic. Usually you have a Redis that needs to be distributed, and then you need to deal with Redis distribution plus Rabbit distribution plus your servers, because your language is not made to actually scale in that way. It's made to scale vertically, while it's not ready for that. And that's when you get the auxiliary systems, the full industry of RabbitMQs, Kafkas, Redis, Memcache, a bunch of things. While in Elixir, the only thing we have is Postgres. That's it. It's what Sasa Yurik had in his talk, that table of other languages. I want to do cache, Redis. What we use in Elixir, ETS, CacheX, you choose, basically.
Yep, exactly.
I want to do distribution, other languages, Kubernetes, Nomad, whatever. You get to the Elixir world, you just do Node Connect. That's it.
Yeah. Well, that's why like DevOps becomes such a it's your sole career. Like there's so many technologies you have to know when you start a distributed system with like a Node.js app. Like it's insane. Like the complexity behind it is so much.
It is. And again, Elixir kind of removes a lot of those layers. And that for me, I honestly believe it's one of the biggest wins. As I mentioned, we do use Kubernetes in a way because AWS kind of forces us to do, because we want to use Fargate, which is much easier to deploy than I want to provision an EC2 instance and do all the VPNs required and all of the AWS suite of products. Not going to say that probably we won't do it in the future, but I don't think it's worth the development time at the moment. Again, that win-lose kind of situation.
I always have this concern, and maybe like I am being dramatic, but I always worry about when you step away from microservices like AWS, you have a lot more development costs because you get so tied in and interconnected, you're like stuck.
Yeah, in our scenario, it's not that difficult. Again, it's basically a Docker image.
Okay.
Since we don't have, first of all, we don't do microservices. Realtime, it's a monolith that is able to. So that's another tenet of Supabase that I really like. Basically, we have a rule that whenever you develop a system, it should be an independent system.
Okay.
It might, and it will probably use Postgres, most likely, but it shouldn't be coupled to Supabase. You shouldn't say, I need Supabase to run my service. If you're doing that, that project won't go up. That project will be killed as soon as possible. Because again, we want to do modular elements that connect to Postgres and not modular elements that connect to Supabase.
Smart. I like that.
It's really good because then your development also focus on that approach of, okay, I really want a piece of a puzzle that is modular. And imagine that for some reason Realtime is not worth it and Supabase kills it. It's possible, it's completely feasible. At that point, no other product from Supabase will depend on it, meaning that you have this decoupled element that could die without any problem. So you don't have that tight coupling with your own services. So it's not a microservice per se, it's just a module you connect against Supabase.
Okay. No, I like that. That's
it's
smart.
a really smart move. I never thought it in that sense before joining Supabase, but doing this kind of modular service, it's way smarter because again, you decouple your product from everything else. It's stupidly powerful. I really like it.
So you're kind of looking at every feature that Supabase adds as a module versus a feature that's getting put in a giant monolith project.
Exactly. And we kind of do it as a separate product almost. You have Supabase and you have Supabase Realtime. You have Supabase and you have Supabase Auth. We need to connect really well, or better yet, Supabase really needs to know how to handle us. But we shouldn't try to do the other way around in a way, right? If our API is good for Supabase, it will be good for someone else, and that's the goal we should achieve. Everyone else should be able to use us easily. And you can use Realtime without Supabase. You just do insert a tenant. This is my database, run it. That's it. Okay. And again, this also helps a lot on the element of deployment, right? CI/CD kind of flows, because then you also package everything as a single thing. This is my Docker container, done. Here it is. This is the envars you need to configure, done. It just becomes way easier to do this kind of stuff.
Yeah, no, I really like that decoupling method. Now it has me thinking about my projects, and I need to approach some of them a little different.
Yeah, you'll always fall into the sense of there will be a monolith in the middle, which is in this case Supabase, the Supabase repo, that will know how to communicate with that modular element. But for that repo, imagine again, Realtime gets deleted. For them, it's a code delete of all the APIs that call Realtime, the UI, but technically that's it. The world continues to go around because there's no big dependencies on it.
I like that. Well, you were a big part of the Realtime project, right?
Yeah, so the Realtime project was started actually by our CEO. I think that was his first project for Supabase. That's our CEO, and I think our CTO kind of were working on this idea of bulk consumption, and they chose Elixir. Then I think they hired people, Supabase got some money, and they were able to, okay, now we're going to do Auth, Realtime will go to a proper team, and Realtime started. So on that development, we had Chase, we had Stas, and we had Wenbo, so 3 developers from Supabase, and they were the ones starting and ramping up the project. And on of Realtime for the last year and something around that.
Okay, awesome. Because I know what kind of got my attention to like wanting you to come on the podcast was you shared an example of a feature you just finished with Realtime, I believe, and I'm trying to remember what it was now because my brain.
Yeah, it's the authorization layer.
Okay, yeah. So you want to explain what you did there and like any big hurdles you ran into using Elixir or anything that you had to overcome?
Honestly, the biggest hurdle was not in the Elixir side. Again, there was one hurdle. There is one more hurdle. We are not able to use Ecto. We need to use Postgres directly because we're doing some stuff that it's a bit more, closer to the Postgres protocol and queries, and Ecto does not abstract as we need. Plus, we would need to manage a lot of Ecto instances. Well, we can only have one Ecto instance, meaning that we need to do repo.with dynamic, which is a way to kind of let Ecto take over another connection. But
Okay.
we need to do that for thousands of databases that are
That
connected. So
sounds
we
so
just
difficult.
it isn't. Again,
No.
it's tricky, but it isn't because again, since Postgres itself, the basis of Ecto with Postgres, it's really well constructed. It's really solid. There's not a lot of problems using it. It's more the side of you need to build queries almost by hand.
Yeah.
I think that's the biggest problem. Fortunately, we actually had a pen test and we passed, so
That's
we were
good.
able to.
I was gonna say, like, that's the scariest part for
Yeah,
developers if they're writing their own queries.
Yeah, it's really scary.
Because I
You
just
better do
had
pen testing.
I had Michael Lubis on again. I think it was just last week.
Yeah.
But yeah, he's paraxial, and we were talking about that. Like basically, like if you're not using Ecto in your Phoenix projects, you got to rethink your life.
No, avoid it. Avoid running away from Ecto. I fully agree with that. I'm fully on that boat. Unfortunately, we had some caveats for this product that we're not able to do.
Well, yeah, you're doing a little bit of a different thing too, and you're kind of providing a very low level service. And
that's the tricky part. So the idea of the feature itself, beforehand, Realtime, if you wanted to do the pusher kind of service where you just connect to a WebSocket and receive and send messages, there was no good security around it. That's the reality. If you had, the only way you could secure it, it's that classical computer engineer way, which is generate a UID v4 and hope no one finds it. That's it. That's the only security we had. And of course, users were not happy with that. It was a feature requested that we should protect our channels in some other way. So what we did is, since we depend on Postgres for a lot of our things, including node discovery, we can also go a bit into that afterwards. Since we use Postgres for a lot of things, we decided, and there's another product from Supabase that did this in the past, which is storage. So basically they use RLS as a way to verify authorization of the assets you can access. So imagine that you have a picture of yourself and you say, I don't want anyone else other than your email to access this one. So that's basically, we did something similar for Realtime. What we do is when you connect, upon connection, we get your JWT token as a user. We load it to the database, all the claims that are important for this and all of that. So you can actually use it in a query. And then you set up an RLS policy query where you say, okay, for the topic X, I only want users with this role to connect. And if you're able to do that, then the WebSocket gets upgraded, you connect, and you can receive messages. Otherwise, the socket will be killed completely.
Okay.
Which is good for us because then we don't spend resources on that specific connection. Plus, we secure the channel automatically.
Yeah, and I love that. That's awesome.
It's kind of tricky because we actually need to add messages. There's a table that we kind of need to emulate for a bit that there's something there. So we can test, is this user able to access it? Yes or no. If they're not, then we basically kill the connection.
Okay. But so you have a temporary, no authenticated WebSocket connection, and then you kind of
in this case, no, because it never reaches the WebSocket upgrade. So you have an HTTP, you have the HTTP 101, I think that's the upgrade call sign, something like that, the status code. You have that. It reaches Phoenix. Phoenix goes through Cowboy. Still, we haven't upgraded to Bandit. It goes through Cowboy. Cowboy tries to do the normal flow of how do I upgrade this WebSocket? It goes through the flow of is this user X, Y, and Z, goes against RLS policies. It reaches a point of this user doesn't have permissions, kill this process, and it goes back. So
you wrote like a plug to enter a plug
Yeah.
And for if you guys are new to Elixir, plugs are very similar to like middleware and other things. They can intercept your connections a little bit. Yeah, rec. So yeah, very cool. I love that. And so that was your. How long have you worked at Supabase? Is that kind of your first project?
No. I've worked at Supabase. I think it will be 2 years in November,
Okay.
something like that. I did a couple of things. So before this, what did I do? There's Supabase bought another company called Logflare.app, which was built by Chase. It also uses Elixir. And there I did, so we use BigQuery on Logflare, but this for self-hosting is a pain. It's a big pain for you to kind of, okay, I want to self-host or I want to run it locally with logs. So what do you need to do? You'd need to have a BigQuery key. And that alone kills local development, for example. So one of the efforts I had to help out with was, instead of basically connect the Logflare kind of ingestion, transform that into Postgres. That's basically what I had to do. And there I started with a really convoluted solution. But in that scenario, we were able to run away from that later with some contributions from another member of the team. And that's an example of REPL with dynamic. So basically removed a bunch of really bad code I did, honestly, now in hindsight, to actually use Ecto. And it worked really well. But that was one of the things I did. I also did no-tail ingestion for Logflare. So basically just consume OpenTelemetry with Logflare. That one is still under development. There's some caveats we need to iron out, mainly also with the interface, because Logflare at the moment shows a lot of logs. We don't have the trace view. That probably would be needed, and other elements around it. And that also was not that difficult. The difficult part was actually load balancers of Google Cloud, because since OpenTelemetry uses gRPC and that gRPC uses HTTP2 to keep a connection alive, load balancers start to mess a bit when it comes to that. But yeah, I've worked with several things. I'm trying to remember more things on the real-time side, but my time has been so focused on on this specific feature that I don't remember anything else other than what I'm working on at the moment.
Yeah, I get that. My brain
goes to mush.
Yeah, and then when you go to look at old projects, you're like, who wrote this code?
Yeah.
And then you find out it was you.
That's me daily. There was actually another fun one, which was at the beginning, we had a bunch of problems where sometimes the database, it's not available yet. So let's imagine that the person has changed to the compute instance or does something that basically blocks the database from doing actions. And we did have a problem of user connects to the WebSocket, and after a bit, they get disconnected or they see errors or something like that. And that happened when the database wasn't ready to actually start consuming information. So one of the things we did was, just add a layer of, let's check if the connection is available. And if it's available, let's keep that connection on the process memory so we can basically distribute it to whoever needs it. And that's one of the things that uses SYN.
I might be like going completely off topic here, but it just entered my head. So I don't use Supabase. If I'm creating like a new schema, how do I handle like my data migrations and things like that with Supabase? Is it through a dashboard or like what?
No, you can use migration. So for example, Ecto migrations would work because you connect directly to the database.
Okay, cool. That's nice.
So it's the same as using Postgres from your Docker container, kind of.
Gotcha. Okay, cool. Because I always were I know we talked about this briefly. I got a bad taste in my mouth because I used Firebase like pretty much when it like first came out, and at first I thought it was the coolest thing ever. This was before I started like working on back ends and like understanding how databases work and all of that. So I was like, this is magical. I can just build my front end iOS app and connect. And then you quickly run into fast limitations, at least with Firebase. So I kind of like abandoned those systems.
To be fair, they were revolutionary for their time. They were insane at being able to launch that and getting the scale they got. Completely justified. but yeah, I do believe that it's better when you use something that already existed, Postgres in this case.
Mm-hmm.
And if you open source it, even better, because then you can really simplify a lot the life of your clients.
Yeah.
It's just a better paradigm of development.
Yeah. I think like, yeah, I don't want to, I'm not trying to trash Firebase because I do think it was like it was really awesome. I think they just kind of lack in the ability to customizable things. So you outgrow it. You can outgrow it really quickly.
Yeah.
And
Yeah, you can. And part of that is also due to the storage, the kind of storage they have being, I think it's closer to document storage and stuff like that. Doesn't help because I've worked in companies that used Mongo, for example. And MongoDB, again, really good, really useful until you reach a point of how do I join stuff?
yeah, MongoDB, it's like the go-to for like it's the cool startup solution, right? And it's nice because you don't have the structure you have, right? You can just like add new tables. You don't have to worry about migrations and all of that.
Until you have to worry about them.
Until you have to worry. Well, until you want migrations, right?
Exactly. I think they're really good products until a certain scale, right? If you have a team of 3 engineers that know how to communicate between each other, then honestly go with a simpler solution. Probably you don't need a schema. That's fine. You can also do no schema on Postgres. And at least then you have a way to migrate out of it. But again, if that's your cup of tea, completely fine. You do you.
Well, yeah, you could leverage just Postgres error handling, right? Instead of using like Ecto or schemas or the change set, I suppose.
You could go through the pains if you want to, basically.
Yeah. I don't think people understand how good they have it with Ecto. That's all.
Oh, no. Yeah. Again, from a large amount of experience on other languages, Ecto has been the best because I've worked with Hibernate, I've worked with Active Record, I've worked with whatever Django gives you. I've worked with a bunch of ORMs, and I hated all of them because I've discovered really quickly that modeling your domain to your database, it's not always the best idea. Ecto gives you the best of all worlds, kind of, because you can still get your model really close to the database, but then you can start to deviate if needed with embedded fields. You don't need to, I don't want to expose everything in my object. That's fine. You just write the schema as you want, even if your migration has 1,000 fields. If your object only needs 10, you can have those 10 and nothing else. So that decoupling of your object structure and your database structure, it's extremely useful. And something that has been, a lot of people, Juke, for example, for Java also did this, and it was a way better experience. And it's just a pattern that works really well. Plus, that decoupling also helps on the query side. I love the fact that we have flexible querying that can be attached to your schema, or really quickly can be completely detached. And you can do, I just want to select one field. Why do I need everything?
Yeah, exactly.
So good.
Well, and just like the speed of Postgres queries is amazing too.
Oh yeah. It's insane.
Just magically get that. Like I'm not going to act like I know what's going on there, but I like the performance.
Yeah, and again, it's since it's all done behind reps. Whenever you have a rep Ecto connection, you actually have a connection pool. That connection pool is managed for you. You never have to deal with it until the day you see, your connection, you're taking too long to check out connections. Easy, just increase the pool, and you don't need to kind of do any kind of tuning other than increase the pool. That's it. It just becomes a really powerful upstream. So is probably, I don't want to call it an RM because it's not an ORM. It's just the best lib I've used for database connections easily.
Yeah. So what happens to you? Like, let's say tomorrow Elixir doesn't exist anymore. What would you do with yourself?
I'll go to Erlang or Glim. I'll just write it. No, if the beam stopped existing, I'd still keep the functional paradigm for sure.
Yeah.
I'd probably run to closure harms and just feel the embrace of closure, or even try to go for F sharp. I just want to keep the closure, the functional programming on my side, because it's the paradigm that really clicked with me.
I agree. And Elixir was my first taste of functional programming. And I think it forces you, like, I think a lot of people, you either have like an engineering brain where you naturally break processes and like tasks apart step to step. But I think when people don't have that, they struggle learning how to program, especially in object-oriented programming. And I think functional almost forces you to think that way. So I feel like the ability to pick up a programming would be a lot faster if you start on a functional language.
I do agree. And some universities actually do that. For example, in Portugal, I think 3 universities actually start with Lisps and Scheme, if I'm not mistaken, and they actually do functional programming as a first language, which is, and again, I do fully agree with you. The way functional programming makes you think, it's what transformations do I need to apply? Mm-hmm. What functions do I need to input into this to result in that? What do I need to do to the meat to become a sausage, basically?
Yeah. Well, everything you're doing in a mutable language, like you should be writing functions like you do with functional programming, right? But you end up doing all these nasty things, and you have these functions that do multiple things, and you just make very complicated things happen, and you're changing global data over and over, and you're doing all these nasty bad habits that you don't realize are as bad as they are until it's a problem.
And you can see people really want to do functional programming, even JS and TypeScript. There's a lot of discussions of, I want to do X, Y, and Z in a functional way, or I want to do a pipeline of transformations. What do I need to do? But then it becomes that issue of the language is not built for that intent. So, for example, I remember some years ago, we had a front end that was using immutable.js, and there was actually a memory leak because of it, where since we were trying to do functional programming, the memory just bloated completely because there were objects that kept piling up and piling up.
I see. Because it was kind of just like a wrapper
clone.
Yeah. Oh, dang. Yeah, bro. But yeah, I don't know. Like, I don't think I ever want to go back because I think it just introduces nasty habits.
Yeah. And even, for example, state management isn't easy. And state management in Elixir, I could say it's easy, but it's also not easy because there's multiple paradigms you can use. You can use ETS as a global storage. You can use the process memory. You can use agents. You can use persistent term. There's multiple facets of storage, state storage in memory for Elixir, and it kind of shows how difficult this problem is. You need multiple ways of doing it, but at least you have those tools. If I need a bag of things that needs to be accessed by any process, I have ETS. If I need to do that, but I need that to be distributed, I have Nisia. There's a bunch of tools within the language itself and the beam that simplify everything. So if I have to leave Elixir, I'll be really sad.
Yeah, I would too. I'd probably become a photographer.
No, I'll go with the farmer route. I'll probably choose farming. Just to
I could do that too. That would be a dream. Big lot of land and just disappear.
Yeah, I'll just go. I'm done.
Yeah. If you're new to Elixir too, avoid. I know I get hated on this because I know like a big reason people come to Elixir is OTP, gen servers, all that stuff. But until you understand the functional paradigm well, don't touch processes and things because you're going to start using them for the wrong reasons, because you're going to want global state, so you're going to just do something nasty and do something you shouldn't be doing.
That's true, and that's a really good call out, because the biggest issue I've seen in a lot of companies that try to adopt Elixir is everything becomes a gen server.
Yeah,
Everything becomes a gen server until someone has that light bulb moment of, why am I doing this? Why do I need to start a process for this? This could be just a pipeline of transformations and get out. That's it.
exactly. Well, like, and
So
I like created my like first project with Elixir. It was a marketplace for personal trainers to sell courses and things. But so it was like there was a lot going on, video streaming, all of that stuff. But I didn't write a gen server for 2.5 years. Like
exactly, you
I was
didn't
just
over
using,
engineer.
yeah, I was just using Elixir and, figuring that out because I was still trying to force weird object oriented things into my project. So it was probably good I didn't touch
How
gen
many
servers or processes.
how many behaviors and how many dev protocols did you try?
I think I started on behaviors. Yeah, it was bad.
That's the
But
first thing. Everyone that comes from object oriented will always go for the this could be an interface. How do I do that?
yeah, well, and it's really hard too. I struggled with the mind shift because you're like, okay,
Yeah.
I know how to do it in JavaScript.
Yeah,
Now, how do I find the equivalent? And like a lot of times you have to accept there's just not an equivalent. There's just the functional way.
exactly. And it's tricky to do that jump. There was actually, I can't remember the surname, Queen. She's a really good Elixir developer. She has a talk in YouTube, something like Atlas of Protocols, something like that. And I really like the way she presented that talk, because it kind of what's done in that talk. It's they've used Elixir protocols with structs really closely to what Golang does, the duck
Okay.
typing from Golang. And it's actually a really powerful abstraction that really gets close to object oriented, because then you can do similar to what Go does. You can say something along the lines of, I have a Postgres connection. Cool. What's my implementation to connect to to just do DB connect if it's the Postgres structure? And then you do the implementation. Okay, for Postgres, I know that I need to do Postgres. But now let's imagine that you have a structure that defines the connection information for MySQL. You could do the same. But you keep that interface of, I have something called db connection.start. How does that .start, how is it implemented for Postgres, how it is implemented for MySQL? So it really becomes close to what Golang does. And it opens another door of, if you are from object-oriented and you want to try Elixir, you could use protocols actually, and it will probably be closer to home than using behaviors. It's quite interesting.
So it's see, I have trouble remembering how to do things in like Swift and JavaScript now too, but it would be very close to interfaces then at that point, right?
Yeah. But it's quite fun.
Yeah, no, I love that.
To delve into that.
We actually have a question that might be a fun one to answer.
Mm-hmm.
How does Elixir's Beam VM optimize memory and CPU usage during high concurrency?
So, first of all, memory is quite interesting. Again, being a functional programming language, this is probably a fact that it's not that well publicized, but it should be. Erlang is built with the functional paradigm, so every element of it, every structure is actually a rope structure. Basically, it's just constructive. It's a tree of changes, and it knows how to prune those changes when they're no longer referenced. And that alone is a big performance improvement in terms of memory that, for example, the one I've mentioned of JS and immutable JS is not able to do, because you clone the full object, you clone the full element. With Erlang, you are able to do this in a memory efficient way because of that. It basically knows how to prune the tree of changes until you reach a certain point. So it's called rope structures, if I'm not mistaken, and it's really good. The other cool thing in terms of memory, it's cool and not cool. Each process, since it has its own thing, its own wrapped process. It's just a beautiful package of if memory, stack memory, everything memory. And that means that each process does have an impact on your memory. So you could actually overextend and store too much in the process. And I've seen this happen. And for that, you should optimize and say, okay, in my process, I should only store, for example, my ID, my reference, my smaller elements, and not full-blown structures full of lists and stuff like that. You should be really careful on what you actually give the process, because otherwise you'll probably reach your memory really fast. So that's one of the caveats. It's really cool because you keep that abstraction of everything is within this box. I have this beautiful box with my compute and my memory and everything, but that box can expand really fast if you're not careful what you're storing in it. So that's one caveat of processes. Still, they are really, if you actually see the amount of memory they use, it's really small until you add your stuff. So again, Erlang optimized this really, really far, because Erlang was used in systems that were not powerful. The idea was really to be used as
like processes alone are very tiny. Like that's why Erlang or the Beam can flex like millions of processes concurrently,
exactly.
kind of thing, right?
Exactly.
And to like engineers back in when was Erlang, like 79?
I don't know. I think it started in 80 something.
Okay.
I think. It has been open source since the 90s. I think it's something like that.
Okay. So, but engineers back then, like you guys, they were so smart because I'm reading through this architecture book for creating like multiplayer, like MMO game servers. And we lost good engineers somewhere along the way. So we got to bring that back, because these guys were building like tribes and World of Warcraft and things on like 24 kilobyte a second internet connections. And you barely had like latency and issues. Like, it is so impressive what they could accomplish back then.
Yeah, and we cry with 100 megabytes a second.
I know. we just, faster internet, more RAM, and we just keep throwing power and resources at our problems. Actually, memory leak, just more RAM, guys.
No, just give it more RAM. There's actually a really good flex from Erlang that shows how processes, for example, are really lean. The Nerves project. The fact that you can actually run Erlang, a version of Erlang, in a bare bones,
like an embedded
Raspberry Pi and embedded circuit. There's even smaller than Raspberry Pi. You can run it with really low memory, and it's still the Beam. You still have some of the niceties of it. You still have processes, and it's there. And it shows that, you don't need to go full-blown big CPU to use Elixir or Erlang. And the question also mentioned the CPU. There's a really piece of magic in the Beam, which is the way they did schedulers. And that, for me, is a dark magic. There's a full Erlang doc about it. But the idea is, if you open, there's one tool within the REPL called Observer. If you do :observer.start, it will show basically a dashboard for the Beam VM. And if you move it to, there's a list of processes that are running, and you'll see something called reductions. If I'm not mistaken, what it does, it's basically the scheduler understands what's the process that's using more reductions and allocates more time of CPU for those, and knows how to turn off processes. Okay. So imagine kind of bringing it to the infrastructure world. Imagine scale to zero. You have processes that are able to just disappear from the CPU until they are called. And this is done automatically with some magic from the Beam. But the idea is, if a certain process has been not doing anything for a while, what the Erlang does is shut down that process. It will keep the state, it will keep everything. And on the first message, it will, okay, I need to wake up this process with almost zero. It's less than nanoseconds. It will wake up that process, do the processing it needs, and imagine that after 10 seconds, it doesn't do anything. Okay, I'll kill it. And that's why, for example, Elixir is really good for millions and millions of processes. because it's really good with this distribution of compute time. It's really good that this process is doing way more than this. I'll allocate more CPU for this one to finish the task. And I'll keep giving a bit of CPU to the others. And you're able to do a lot with it. Plus, it also takes over the full CPU. You don't need to... I was having this conversation recently.
It's like a built-in load balancer for
Exactly.
processes.
Yeah, it's beautiful. I was talking with this recently with a couple of friends, which is, again, I've worked in the Rails world, and most of the times to scale up Rails, what you need is basically fork the full process. It's you have inside a server, you have 10 instances of Rails running. I'm not sure if it's like this anymore, but at least from what I've understood, it's still a bit like this. But correct me if I'm wrong, and I hope it changed a bit. But before it was, there's a fork, there's a fork, there's a fork, and it's basically the full OS process. And that actually takes a lot of resources, right? You're basically loading everything, and probably you don't need to load everything. Processes are that in a way leaner way, and it's almost an abstraction on top of your operating system. That's how I feel, at least. And again, there's a lot of correlations between the infrastructure world and Beam. It's like you've said, you have a load balancer that knows how to distribute work. You have a garbage collector that basically goes process by process and says, you're not using this, get out. There's a scale to zero component that knows, okay, the scheduler knows that this guy isn't doing anything, so stop giving it resources if it doesn't need it to. And again, there's a lot of optimizations like that the OT team did. They're just insanely good. I don't even know what kind of magic they did. It's like you said, there's engineers that are just way above genius. I don't understand what they did, but it's beautiful.
Yeah, I've accepted that I'm not one of those. I'm really good at using tools of other smart people. But I know my limitations, you know? But
exactly.
Erlang's debut, Tamir said it was 1986. I should remember that because it's a year younger than me.
But 86, so it's about to do what? 30 years?
So,
in a couple of
years? 38 years?
Yeah. So yeah, we're talking about the language. That's the other thing that I disagree with a lot of comments, which is, have you used it in production? Who is using it in production? Well, the roots of the Beam VM have been used in production since 86. It's older than JVM.
Well, it was our phone system, systems essentially, right?
So it was our phone system. Cisco actually said that 96% of the traffic worldwide for their routers actually goes through Erlang. So their routers actually had Erlang embedded in it. There was also Call of Duty. Infinity Ward actually used Erlang for their servers. There's a dark paper hidden somewhere from DevCon from 2000 and something. Nintendo used Erlang with Azure and notification systems. Pepsi uses it. That's the caveat of it, which we're talking about generations of developers that actually have used it, and people kind of insist that no one uses this specific thing. And honestly, it's kind of a lie. Probably they don't use Elixir, but Erlang itself has been used for the longest time. It's a really solid language. If you don't want to do Elixir, do Erlang. It's good anyway. It's a really good language. And again, it's just the VM itself. Again, it's older than JVM because Java was developed in the 90s. It's older than JavaScript because JavaScript was developed by Netscape, if I'm not mistaken, at 96 or 94, something like that.
Yeah, I think 94 sounds about right.
Right? I think it was something like that. So from all the languages we use and say you don't use it in prod, well, actually, Erlang is the oldest probably that.
And let's be honest, JavaScript shouldn't have gone as far as it has.
There's hope with WASM, I guess, but...
Oh man!
But yeah, I do believe that there's a bit of a sunken cost fallacy and that makes sense. Honestly, you don't want to get to a company and when you arrive there, I want to rewrite everything in Elixir. There's a big reason not to do that, of course, which is there's costs to that. How long does it take to migrate the full system? But it reaches a point of, again, sunken cost fallacy of it's making money. It's been like this for 3 years. It's full of bugs. We spend more time fixing bugs than actually doing development, but it's making money. At that point, you kind of need to think about it and go, should I refactor it? Should I change it? Even if you keep the same stack.
Yeah.
Just think about it, because
that's the worst cycle too. And like, I've been on teams where, you can't afford to do a full rewrite, and you're sitting there, instead of implementing new features, you're fixing bugs. Yeah. And then to add new features, it's almost impossible because of like certain code architecture and things that are already happening. So you get in this weird paradigm where new features take 4 times longer than they should. And then you introduce more bugs, and then you have that bug that keeps popping up again and again after you fix it. It's the worst.
That's another thing where I truly believe that functional programming kind of helps, because a lot of the bugs I've seen in my life most of them was global state.
That's normally annoying. What it is. You have you have
side effect.
Usually you have a side effect and a race condition that's really hard to replicate, and you don't run into it enough, but you run into it enough that it's a problem.
Exactly. Yeah. And again, most of the bugs I fixed in my life probably were due to that bad state management, changes that happened in a time you didn't expect. It's stuff that happens because the world doesn't use a single clock. It's different everywhere.
It actually reminds me of a really nasty bug. The last iOS job that I had, I inherited a crazy code base that took me, I don't even think I knew everything that was going on with it. And I was there like 3 years. But I was trying to fix a bug. So I was tracking down things, putting logs everywhere. And the biggest mistake I made was to assume a singleton was a singleton. And when I finally discovered that it wasn't implementing as a singleton, I found out that we were creating like thousands of processes, and we couldn't figure out why our state was getting out of sync. And like sometimes it was in sync, sometimes it wasn't, because we weren't controlling what instance of the singleton we were calling. It was such a nightmare.
That has a special element of evil. Calling a singleton and not being a singleton, that's special.
I know. And you would assume, and when you looked at it, it was set up as a singleton, it should be good to go. But something, I don't remember what it was, but I had to do a minor tweak, and then found out it was actually a Swift related bug. And then once we figured out why the singleton wasn't implementing, we fixed the major problem. But it was one of those things that was horrible. No, I was looking at a memory map, and I was like, we have it was just a nonstop infinity growing singletons, right? And that's also a big problem with how powerful phones are and our computers, things like that. That's essentially a really bad memory leak.
Yeah, it is.
They're hard to find sometimes.
They're hard to find, they're difficult to replicate, and they might take 1 minute or 1 hour to actually reach that point.
Exactly.
And that's really difficult when you have, for example, long-running processes. I've worked in companies where the memory leak existed, and it was the job of someone to restart the machine.
Oh gosh, yeah.
Because it was a long-running process. And now imagine this for a data pipeline where you're just constantly ingesting data, you cannot stop, and you have memory leaks everywhere. Or you even just have one memory leak. It's hell on earth. That's why, again, there's a lot of hate against VMs. That's one of the things that VMs do really well. And for example, Go also does it really well. The fact that you don't need to do memory management, for me, it's almost mandatory in a language.
Yeah, it's not fun to have to deal with garbage collecting manually.
Yeah. At least for 90% of the problems in the world that we try to solve, there's no need for full-blown memory controlled, basically.
Mm-hmm.
And again, Elixir really shines on that because it's something you never think about. Basically, you create a struct. No, there's no malloc, no free, no nothing.
Yeah, exactly.
Simplifies things. Plus the fact that it's almost 40-year-old VM, it's highly optimized for that. It's highly optimized for memory. Again, it just shows how good Joe Armstrong and the other guys did the VM that they did. It's insanely good.
Yeah, it's incredible, honestly. We are very lucky.
Yeah, completely.
I don't know if you want to circle back around, but I know you wanted to talk about dynamic nodes or
yeah. So we can actually talk a bit about node discovery. So
node discovery, that was it.
One of the things that people see kind of as a deterrent to not use Elixir in a clustered way is actually node discovery. Chris McCord did already an awesome job with this. He released DNS cluster, which is, and it comes with Phoenix. If you do mix Phoenix install, it will come with the DNS cluster lib. And it's just name discovery with, well, DNS. So if you set up everything correctly, you just need to say, point me to this, and this address, and the node automatically connects. Mm-hmm. We couldn't do this with AWS because we don't have name discovery for the nodes itself. We're basically using IPv6. So what we did was, instead of using that, we used lib cluster, which is a great lib to actually connect Elixir nodes. And we do lib cluster with our own adapter that we've released open source, which is using Postgres. Postgres has the listen notify commands, where you can basically broadcast using Postgres. And we use that to listen. So when we ramp up a node, we start that listening module of, I'm waiting for a message from the remainder of my cluster. The other nodes basically understand something new is trying to connect. They send their IP via Postgres, and the node that tried to join just knows to, okay, I need to connect to this, to this, to this, to this, to this. So again, another abstraction that in other languages would be, I need Kubernetes, I need to set up Helm. I think that's Helm that does the orchestration of service A, B, C, etc. Mm-hmm. You kind of go around all of that. It's nodes connecting to nodes via IP connections, TCP connections purely. And again, it shows that even those elements are quite easy. They're not easy. They're close-ish to easy. They're not a big problem. And again, if you use, for example, if you have name discovery on your nodes, for example, Fly does have name discovery. So they have names for each one of your machines. You can just do the DNS clustering for service discovery, and they'll basically automatically connect and reconnect if they die. It's extremely useful. It's basically zero cost for the Elixir side. And one of the advantages here is, again, if you look into the WhatsApp conversation, the WhatsApp presentation I've talked about earlier, they actually do this they have specialized nodes. So imagine you have a cluster of Elixir machines. They're all connected. They're all happy. They're all really happy with what they're doing. But one does mathematics, the other does grammar, the other one does AI, whatever. Mm-hmm. What you can do is actually, since you can name them and you can group them in clusters of things they can do, you can actually say, okay, I'm a web worker. I want to do a grammar thing. Okay, then call the grammar cluster and let one of the nodes pick the job and do it. Cool. Mm-hmm. They'll do it. They'll return the answer. So you can kind of do specialized nodes. You can do node balancing between them of when someone sends a message, you can do even a really simple thing where you say, okay, my CPU load is 80, mine is 60, mine is 40. Cool. Then I'll send it to the 40, the one that has 40 CPU loads.
Is that something you have to manage, or is it?
That would be something you need to manage, yeah.
Okay.
But again, it's kind of low costish, because then it's just RPC calls going back and forward. You could do, okay, me as the web guy, I'm going to send to the grammar guy, what's your load? 80, 40, something, cool. The node that responded with the less, I'll send the RPC call I really want to do, focused on this task.
Yeah.
So, and we're talking about potentially 10 lines of code to actually do this, because it's just messages going back and forward quite easily.
Which is wild, because that just shows you the efficiency you can have on a team too, just staying in like the Beam VM or like Elixir and Phoenix. You can go a lot further with fewer developers, which is great for startups, you know?
Again, I'm currently managing a system. I'm doing support, I'm doing development, I'm doing client libs, and I'm basically doing also planning of what's the next feature and stuff like that. I have my manager, and we basically are async, and I tell him, look, I need help with X, Y, and Z. I ask another 2 colleagues for code reviews, basically, nice. And they'll code review everything. But other than that, I'm basically alone maintaining it.
Okay. How many Elixir developers at Supabase?
We don't have a lot. So we have 1, 2, 3, my manager 4, fifth, and a 5th one that is joining. And I think that's it. I think 6 in the company, 6 people. Oh no, actually no, it's more. There's another one that knows. We've had 2 or 3 people that joined from Snaplet, and they also know Elixir.
Okay.
So we kind of doubled the number of people that know Elixir in the company.
That's awesome. But like, you're probably all getting a ton done though, because of.
Oh yeah.
Especially if you're, like you said, you're kind of siloed on your projects. So I'm assuming that's how every Elixir developer is. Then they all have their own projects. Which
everyone
is awesome.
Everyone is doing their own thing. And again, for example, one of our projects, it's called Supervisor. Supervisor is a connection pooler for Postgres, and it's managing thousands and thousands of connected clients. It's insane. Basically, almost every connection made against Supabase, it's going through that connection pooler. And at the moment, it's a single developer doing it. We're getting the second developer there to kind of help speed up and even maintenance work. But again, it's insane what you can do with a single developer if you are on the right stack, which we do believe we are for this kind of use case.
Yeah. I mean, I tell everyone too that if you're a single dev, build your product in the pedal stack, you know, like
completely.
You can accomplish so much.
Yeah, and we don't touch that much in live view, because if we actually needed to do front end stuff, live view also helps with a lot. For example, Logflare, which is the company that Supabase bought, the only company Supabase bought, which is basically a logging service. We do use live view, and we use it with live React, something like that. And again, that single developer is able to do front-end work, is able to do back-end work, and live view is a big chunk of, okay, I can remove a lot of things from my world, including state management, because since state management is done on the server, it's done with good primitives. It's done with, I want to keep this in the process memory, I want to keep this in ETS, etc., etc. You remove a lot of the barriers for front-end development. That's why I really think live view is one of the best abstractions that came out in the last years. And everyone else is kind of also looking into it as, they're right. That's why we have Livewire for PHP, Turbo and Dotwire for Rails, and they just keep appearing.
Yeah, for sure. Well, I mean, the speed of the server-side rendering and not fully updating everything is live views,
so
you
good.
know. Yeah. I always avoided. So I was an iOS developer, but then I kind of transformed to back-end development with APIs and all that. And I avoided front-end web development.
You should try it again.
Because I hated it. But then, I started it again because my YouTube channel, everyone wanted me to do like a live view stuff. So I kind of like, I created like a gist clone, and it's me kind of learning live view as I build a project. But like, it's great. Like I enjoy, like my weakest part of front-end development is like just knowing Tailwind, honestly. But then everything else is so easy.
I'm in the same field. Basically, whenever I do live view, I have one side with VS Code, the other side with Tailwind docs.
Yeah.
That's it.
That sounds about right. But yeah, Tailwind is like my slowdown for sure. Everything else is so easy.
Yeah, and for example, I'm kind of building a side project with a friend at the moment, of course using LiveView, and the biggest problem is exactly that. When you need to do UI, the biggest problem is not the live view part, it's styling it. That's the annoying part now.
But yeah, my patience with styling, and then like nothing works the same in Safari. I was like, how do web developers deal with this on a daily basis? I hate it.
It's basically acceptance. I think it gets to a point of, okay, yeah, we're not using this as a feature. Let's move to something else, and then
yeah, exactly. Yeah, because I built now like elixirmentor.com, that's live view, hiredgunapps.com, that's live view. And I have a bunch of new clients now because I built like a website hosting platform.
Nice.
In Phoenix, and it's working fantastic. And so now I have all these websites that are built in live view, and they're all working great. So it's awesome.
Yeah, no pain, right?
Yeah, no pain.
I have a small blog of my own, and it's really small, no traffic, no nothing, but I haven't touched the server for, I don't know, 1 year.
That's amazing.
I think, and it doesn't go down at all. And that's one of the things that, for example, Realtime, we also see the advantage. I'm the one maintaining Realtime. I might be speaking too much because usually when a person says this, there will be an incident.
Just knock on wood really quick.
Yeah,
you won't.
But the thing is, there's a lot of self-healing elements to it, right? Which actually brings to another problem we actually had that could be an interesting discussion. But since Erlang gives you supervisors and processes and whatsoever, all of that, the idea of the supervision tree of, I know how to self-heal, it's extremely, extremely, extremely valuable. I think it saves us daily almost for sure, because any error or bug that the system doesn't know how to interpret, it just kills the process and brings it back up. And that's it. And it self-heals most of the time. We did have, and now comes the interesting part and one of the caveats of using Postgres instead of Ecto, which was, since we are starting a connection using Postgres, it's actually using Postgres is a layer of multiple things. One of them is DB connection. DB connection is actually the thing connecting to the database. Postgres is a wrapper on top of that. And what was happening was, on the module where we check if the tenant database is alive, we open a Postgres connection, we try to do something, okay, it worked. We tried to run migrations, and for that we use Ecto with dynamic. So there's some caveats there, but since it kills the connection, we can do it. But yeah, it tried to run the migrations failed for some reason, and it would go in a loop, and in a loop, and in a loop. So at some point, we'd see just a spike on the number of processes created. The problem was there's multiple ways for you to shut down a process. And this is probably an important lesson for anyone trying to do processes.
So you had like a runaway process,
exactly.
Just getting created, kind of like my singleton problem, but with processes.
Similar to your singleton problem, similar to the immutable JS of just creating stuff for the beam.
Yeah.
But it didn't kill the server. What happened was it spiked the usage for that specific client. It didn't kill the service, but it killed the database because it just created so many connections against the database that it kept failing and failing and failing. Realtime and the beam doesn't flinch.
And then you had kind of a waterfall effect, though, probably, where all those processes DB connections were failing.
Yes,
or no?
And it was just creating more and more and more. But the good thing is it kind of self-heals on the server. It killed the tenant database. And that was the biggest problem. That's how we detected. The problem was stupidly simple to fix, and it was just—
They usually are.
Yeah. It's read the manual. I don't want to curse, but yeah, read the manual was there. If you look into the Gen server documentation, you actually look into terminating the server, and you have two ways of doing it. during the init callback and during the until continue and in every process. So you can return okay and the state basically okay, continue, and whatever step you want to do, continue. And if you want to stop, you do a tuple of stop, colon, and normal or shutdown. Normal doesn't kill the child processes. Shutdown kills the full tree. And that was the only bug. So basically the fix was changing one line, slamming my head against the table and saying, next time read the manual before doing anything. And that's it.
Yeah, well, it always is something like that, right?
It is. It's always that colon, that atom that we didn't know. It's just, again, naively thinking that it solves everything.
I can write a book about my naive thinking until that's where you learn everything, right? You need that. You need
to bang your head. No one will ever be perfect coding. I bet. I hope I continue working in programming for the longest time, and AI doesn't steal my job, and I keep working with Elixir and whatsoever. But I know that if that's my career in the future, in 30 years, I'll still do really stupid mistakes. It's part of the human nature to do mistakes like this.
You just won't do ones you've already made.
Well, depends.
Hopefully. Well, yeah, we'll see. Or you'll be like, oh, shoot, I remember I did this 20 years ago.
Exactly.
But you'll be faster at solving it.
It shows that there's consequences with choosing Elixir. There's consequences there's still things you need to know about how things work.
Yes.
But again, it's a difference between one line of code, basically changing a tuple, and okay, now I need to backtrack. And is it on Redis? Is it on RabbitMQ? Is it on Postgres? Is it on the Rails server 1? Is it on Rail? You need to find a bug in a ton of abstractions. While in Elixir, if something blows up in real time, there's only two things: either it's Postgres or Elixir. And the visibility tools for Elixir are really good, so it kind of becomes easy. Okay, I see that there's a ramp up in processes. What could have triggered that? I go into Live Dashboard, which we use. So we actually use Live Dashboard for us, and I've even added a tab to do process dump of everything. I've added the custom tab of give me all the Erlang terms and download a file telling me this is the full process tree, so I can debug it locally and understand what's creating too much processes, what's the tree looking like. So even to find a bug, there's really easy ways for you to do it versus, I don't know, I can't even remember profiling tools for other languages that work in production.
Well, I think like web dev in general usually sucks for profiling tools.
Yeah, it's tricky. Yeah, you only profile it on the browser.
Exactly.
And then it's too late.
And then now Xcode had really good tools, but Xcode is a conversation of why you hate Xcode for numerous other reasons. But I will say debugging with Elixir, that would make really good YouTube content, going through some of that, like how to see all your processes, how to see what's happening.
It would, because again, it feels like a dark magic, but if you look into it, it's the easiest thing ever. To get the process dump, it's basically process list and Erlang. It's not binary to turn to binary. So it's two simple commands, and it will dump you a list of tuples. It's ugly, but you're able to do work on it, and that's it. And it's not that difficult to do, and you can even develop tools around it. Imagine that you want a tool suite of, I want to understand how my supervision tree works and grows and does things. Then you could even have a cron process that just dumps this to, I don't know, a server, Slack, whatever, just dumps, and you can look, okay, I see that during this time of day, there's a lot of processes, so maybe it's not a good time for deployment. You can even do processes around it. So it's quite interesting what you can do, and really low code. It's not a lot of code to get this information.
That's actually really smart. Like dynamically do process or tasks around how many processes are running.
Yeah, and it can simplify a lot of things. For example, from those processes, I can tell you that at this time of day, I have X amount of connected users via WebSockets because what they are using, it's Cowboy. So I just need to count the number of processes that have the spec of Cowboy, and that's it.
Mm-hmm.
So there's a bunch of small things you can do, even analytics on top of it.
Yeah.
There are just quick helpers that you can have in a module. You can even do it in.
I just do like cron jobs, right? And just assume not as many people are using my services at like 2, 4 a.m. or whatever it is. And, you just run your tasks. But I really like the dynamic approach. You could actually approach.
Yeah. It could be if you have a cron job, you could tell that, okay, my threshold to do this task is 10 connected users. Then it's not a problem.
Mm-hmm.
Okay, check how many connected users exist. If it's more than 10, stop. Done. We will do it at another time.
Yeah. I love that. That's a great idea. See, now I have more work to do.
And to give you a bit more work, there's also the approach of hot code reloading, which is a world that it's awesome. And
I need to, like, I am aware of it, but I have not used it.
Supervisor, the one of our things uses it because since it's a connection pool, you cannot kill the connection pool of a customer willy-nilly.
Right.
So we actually
you shouldn't. You can.
You shouldn't. You can, but you shouldn't. It will open tickets. And it's just annoying for the customer. And the thing is, so Stas, one of the developers here at Supabase, he came from the Erlang world and is just magical. He actually developed a full thing on his own where supervisor, when he wants to update supervisor, it checks if the connection is alive. If the connection is alive, don't do anything. When the connection goes down, it basically reloads the module for that specific process. So then the user doesn't get disconnected. But at the next time they connect, they'll already have the new version of the module.
That's
you can
awesome.
do a dance of dynamically loading modules with the state being moved from one to the other. It's again magic that Elixir gives you.
With like now that I have like my little website hosting platform, I need to do that. That would be awesome.
You could say zero downtime, almost high availability. There's no maintenance window because everything can be done dynamically. Yeah. And for example, for the hosting, if it's a hosting website, probably if you just do hot code reloading, they wouldn't even notice. Most likely.
Well, it wouldn't update the module till no one's connected to that specific module, right?
Yeah. Or you could just update them all, and since you're using live view, they will just remount and continue their life. It will depend on what you want to do, because if they're using live view and doing dynamic stuff, then you'd want to retain the state, because there might be state within that live view that you don't want to mess with it.
Well, there's both. So I would say the majority of my websites are just static, so that it doesn't matter as much there. But I do have live view stuff for like blogs, podcasts, things like that.
In those scenarios, you can still look into, I'll retain the state and even move the state. You can tell it, my recipe to move from version 1 to version 2 is I'll grab the state, I'll transform the state in this way, and I'll push it to the version 2, and that's it. Mm-hmm. And Stas is basically doing that. He's doing some state management of, I'm going from this flow to this, from this module to this module in versioning, and this is how you do it. This is how you transition to that. It's quite complex, quite complex, and I really want to do it to Realtime because it's another app that would benefit from it. But again, it will take time because it's not an easy thing.
I might have to reach out to you and start talking to you about it when because I feel like that's something.
I also need to explore this issue, honestly.
All right, because this is actually something I need to figure out relatively soon, so I should dive into it. It would be cool.
Yeah. If you want to,
like one of those
signal,
things. It's just my list of features.
Another one, right?
Yeah.
If you go to the App Signal blog, they have a really good, I think it's 3 articles about hot code reloading.
App Signal?
It's App Signal, yeah. They don't give you the state management part, but they'll give you I want to dynamically deploy things. And it's basically, here's a tarball of the new code you need to load into Erlang, and they show you how to do it.
Awesome. I'm going to pull that up on my browser so I don't forget.
It could be a good one for you to dive in a stream.
One of my 100, that would be a great, actually, I could attempt to work on it live.
It's not a bad idea. It's risky.
Yeah. Well, I think like coding live is cool. You just have to accept that you're probably going to look like an idiot at some point.
Oh, yeah.
I think that's okay.
It's something I really like to do. But again, I still, it's like you said, I'm a bit afraid of how I will look. But at the end of the day, I think everyone, even the smartest person in the world, will look stupid at some point.
Yeah. So, I mean, people might as well know what I look like off camera when I code.
Exactly.
We have a question. I think we both can answer. If I want to learn what you guys know, what would you guys recommend? I read the docs.
Read the docs, but there's actually a really good website from a future guest of yours, Peter Ulrich.
Yes, Peter's been on here in the past too. He's awesome.
I've worked with him at Remote, and he was my team lead, and he's really good. Yeah. There's a website called runelixir.com. That's a really good start. The usual read the docs is also useful because this in other languages almost is like an insult and giving you go away, I don't care. But in reality, in Elixir, it changes completely. If you
Elixir docs are usually really well done. I mean, obviously, depending if it's a library, maybe not. But like the core docs are amazing.
Yeah, and Ecto, even Ecto has really strong docs. If you look into the tab so there's a space, kind of a getter element, and if you go to guides, Ecto has it. Rec has it, Elixir has it, Phoenix has them. So basically the main things you want for the 99% of your problems that you want to solve, those libs will give you a really good guide on what you need to do to achieve it. So
I also know a really good YouTube channel called Elixir Mentor.
There's also that. And that's the other part.
I have a great basics playlist that like goes through types and like all the stuff that you have in other languages, but we do examples and I write them out all in Elixir. So you learn like the pipe operator and immutability through examples. And then like a couple months ago, I started doing live streams where I read through the getting started guides, the meta programming guides, the anti-pattern guides. So you're just reading documentation with me and then I sit there and try to figure it out.
And even your tutorial about how to build GIST, that's probably also a great reference because then you'll see state persistency, you'll see live view, you'll see a bunch of elements of how do you actually develop an app in Elixir. And you'll start to see, okay, how do I connect this with JS? In my JS world, how do I do this? Yep. And then you end up seeing, okay, it's not that difficult. I just saw how to do GIST in a couple of tutorials and it didn't feel difficult. If you follow along, then you'll start to find the autocomplete stuff, and then
what's wild too is seems like a cool dude. Yeah, the Elixir Mentor dude, he's really cool. But what's wild is like when you're just building a live view app, you have your context layer if you use Ecto, right? So you have your CRUD operations and everything's kind of magical. And you have your front end update dynamically because you don't really have to think about much. So when you learn like the basics of event handling and mount and all of that, it's like, it seems almost too easy.
Yeah, it is. For example, I have in my blog, I was exploring how to do live view. And in my blog, I wanted to do something different because that's another thing I probably advise for people that want to learn. It's just do stuff. Everyone has its own learning way. So that's also a caveat. I, for example, don't read books because I'm too lazy and I get lost in words. So I avoid technical books. So my way of learning is doing stuff. And I wanted to try out live view. And one of the things I did was just have in my blog, I have a small bookmark thing, and it's dynamic. If you go up and down, every other user that's in the website will see it. So, and it's basically Phoenix Broadcast, and I go through the blog explaining how to do it. And again, I only learned it because I did it. It uses Phoenix PubSub, it uses hooks from LiveView. And again, it's just learn by doing is a really good approach, at least for me.
I am that way too. I read a little bit, like, especially there is like a lot of limitations in Elixir. It's getting better, but it's hard to find specific topics. So if I need to learn something specific, I'll read. Like, I rarely will read a technical book from cover to cover, but I will go into what I need, because technical books will put you to sleep real quick.
Yeah.
But building a project is definitely the best way, because even if you build it wrong, you'll eventually learn you built it wrong and you go back and fix things.
Yeah, exactly. Every bug, every toe you stub against the wall, everything you do in your application will be a learning experience without risk. And I do believe that's the best way to learn. But again, learn at your own
whatever works for you. Like, people love watching me read documentation. I personally wouldn't tune into myself reading documentation, but it's a lot of fun when people like interact with me while I'm doing it. And so
again, because they probably will see it in a different way. It's kind of an audiobook. Some people connect with audiobooks, so it becomes easier for them to also absorb that knowledge.
I think like conversation-based learning is good too, right? Like just us talking right now, like I've learned a lot today. And unfortunately now I have more things to do, but but like just having conversations with other engineers, you can learn a lot.
Yeah. For example, I got lucky to present at ElixirConf this year. And no doubt the best part about a conference is, I wouldn't even say the presenting part, that's cool and all, but the best part is now I can actually mingle with people from the ecosystem I like. And you end up, again, like we're having this conversation now, and now we'll get out of here and need to code for the next couple of hours and open tabs and close tabs and whatever. When you go to a conference, it's exactly the same. You will get out of there just full of ideas, full of, I need to do this and that and whatsoever, just to try stuff, because you get completely hyped.
The conversation will fill you full of theory, right? And then you have to go home and figure out how to implement it.
Exactly.
But that's the best part, right? Because like, how many times are you so close to a problem you can't solve it? And you're just beating your head against the wall, and then just describing your partner or your problem to another person. Yeah. You solve the problem in that before you're even done and they even open their mouth. You're like, I'm an idiot. Like, I can just do it this way.
Exactly. Yeah. Just talking about it makes your brain, piece together things in a different way.
Yeah. And pull requests, reviewing other people's code is huge.
Yep. And again, open sourcing. That's one of the reasons why open sourcing is so good. You end up with really useful discussions.
When you're brand new, when you're learning a new language, dive into open source projects and code, and you're going to you might not understand what you're reading. And I think that's okay. Because I actually think it took me a while to understand everything going on. When you see a really well written project, like I didn't really understand, underscore module. And I didn't really understand that was just passing in a module name and things like that. Yeah. But when you start seeing that stuff and like reusability stuff throughout a code base, you learn a lot.
Yeah. And not only that, you shouldn't be afraid of, even if it's copy pasting, that's fine, because for sure you'll get to a point of stuff like there's already a process with this name. Usually that's the underscore module underscore pitfall, is when people try to name their process with the same name as the module, you'll end up seeing that error and you go, why is it complaining about this? And then you'll see, okay, there's already a module called, there's already a process with this name, which is the module name. So then you connect the pieces of, oh, damn, this just is a macro to give me the process name, the module. it's again by hitting your wall against the code that you'll end up discovering a lot of this stuff.
Yeah. And I remember when I first learned of gen servers, I was like, all right, I'm going to try this out. And I was like, I just couldn't understand it. I was like, this doesn't make sense to me. Why am I statically creating a process? This will never work. Like, it's not ideal. But then I learned about dynamic supervisors and gen servers. And then you start learning about how you have to have good dynamic names so you can call that process. And it's like you kind of go down a rabbit hole and you force yourself to learn things that you didn't know.
Yeah. And again, most of it is in the docs, which is the other.
The docs are amazing. I will say, just go through the docs. And if you want to hear the docs, read in my voice, head over to my YouTube channel.
Exactly.
But awesome. We've been going for like 2 hours. This it goes quick, man. But,
yeah, it does.
Filipe, thank you so much for coming on and joining me. This was a lot of fun. I don't know if I should thank you because I have so much more work to do now.
Yeah, you should insult me. Just say, no, you've messed up my schedule completely.
Yeah, now I like ADHD brain has all these tasks I have to get done. But
now, if anything, I'm the one that wants to thank you. And again, I really think that this kind of conversation and this kind of show, let's call it, it's important because people need to be aware of Elixir is used in production. What's the caveats of using it in production? There's a bunch of things that usually are not that well talked about. And this is the kind of place where this can be talked about. And it's important that this happens.
Well, I also think it's important for people to know when you're picking a tech stack, especially if you're starting a product or a company, you're not just picking a tool because you like that tool. You need to know your limitations and requirements of your project.
Yeah, completely.
And I will say Elixir fits most of them, but there are going to be limitations.
Oh yeah, don't try to do a game in Elixir.
I'm like very tempted though to try.
You can, but if you want to do a game like computer game, really, I think it will be tricky. There's no good Vulkan drivers and stuff like that. Just saying that I did explore that really high level, and I said, nah, I'm going to lose too much of my life here.
I might have missed a question. Let me see. Did I miss the answer to macro-powered dynamic naming? Let me look.
If it is.
What about dynamic descriptive naming, similar to the via tuple, but macro-powered to take name from a spec? I don't know if I understand it.
Don't forget on that scenario, don't forget that macros are compile time, meaning that probably you might be able to do something with that, but I'm not sure if it would work. For that, the best way, at least for naming, if you're starting the project, use the global registry and just give it a tuple of your module and some attribute of a key. Registries are also really good.
I see. I understand the question now. Yeah.
What was it?
Let me read it again. What about dynamic descriptive naming, similar to via tuple, but macro powered to take a name from a spec? So yeah, I think you'd want to use global naming, or like you'd have to have some sort of, you'd have to have a little bit of like a config file of some sort.
Yeah, then registries and global would be probably the best way. Yeah, because again, since you're already in runtime and macros only work on compile time, you'd probably be able to do a macro that generates the name based on whatever you need. But at that point, you might just want to go with registries, with global, with syn, again, with other ways of registering your client, your process name.
Yeah, awesome. All right, guys, thank you, everyone that tuned in.
Thank you so much.
I hope everyone has a good weekend. And thank you again, Filipe, for sharing
all
your experience and mind with us. I appreciate it.
Bye-bye. Right, thank you so much.
See ya. Testing.